Hey, welcome to Unit 12, the ocean's role in weather. So, the ocean regulates temperature content and moisture content, and temperature and moisture are the two things that really drive weather. So if you think about it, drought, not a lot of rain, really hot. Blizzard, lots of rain, really cold. Storms, lots of rain, tornadoes, hurricanes, driven by temperature and moisture. And if you're thinking to yourself, well, yeah, but what about wind? Because, tornadoes are wind, hurricanes, destructive wind. You're right, wind is a correct observation. However, wind's actually caused by pressure differences, which are actually caused by temperature differences. So temperature and moisture are the two things that drive weather. Let's talk about how wind forms. So wind is actually just air moving from high concentration to low concentration. It's a natural movement. If you think about diffusion, the movement of things from high concentration to low concentration, that's all wind is. However, high concentration and low concentration are caused by temperature. Low pressure is caused by hot air. So as air warms up, the molecules speed up and the volume grows. Lower pressure, and low pressures are generally associated with cloudy, rainy, snowy weather because if it's wet or warm, there's more humidity in the air, more evaporation of water, which leads to clouds, rain, snow. High pressure is caused by cold air. So as air gets colder, the molecules slow down, they compact, that pressure increases, and high pressures are typically where you have happy weather. So remember with wind, it moves from high concentration areas that are cold to low concentration areas that are warm. Because of that, you'd expect that wind would move from cold polar regions to warm equator regions. The equator gets more of the sun's rays. The polar region gets a more diffused exposure to the sun's rays, so it's cooler. And that's actually what you expect to see. And it's what you would see if the Earth didn't rotate, rotation wasn't tilted, and the Earth had no water or land mass. So what you can see here is that here's the polar region, here's the equator, and what we would expect is wind would move from the cold polar region to the warm equatorial region. And if the Earth didn't rotate, if rotation wasn't tilted, if the Earth had no water and land mass, circulation would be really simple and the weather would be really boring. But that's not what we see. Instead, we get this. So I want to point out a couple of things. This region here that I'm going to put in green, this region here that I'm going to put in green, this region here I'm going to circle in purple. Okay. So if we look at the first green region, this one right here with the trade winds, notice that the wind's moving from about 30 degrees north down to the equator. So it's moving from a colder place to a warmer place, and that's what we would expect to see. If we look at the polar highs and the polar lows, this region here that I put in green, you see that the wind is moving from the coldest pole towards the equator, moving from cold, high pressure to warm, low pressure, again, what we would expect to see. What we don't expect is this region here that's in purple, these westerlies. These westerlies are moving from warmer regions to colder regions, which is not what's supposed to happen. But the reason why is this is what we call a forced cell. It's moving the way it is because it's forced to move that way by the subtropical trade winds and by the polar winds. And this is because these trade winds are moving in a circle this way. These polar winds are moving in a circle this way, and they act like gears forcing the westerlies to move the direction that they do. So what we see on the left, this globe here, this occurs because the Earth is tilted, because the Earth rotates, and because we get the Coriolis effect. So notice that this wind, as it moves down, is veering off to the right. It's in the northern hemisphere, it's going to veer to the right. This wind, as it moves up, is veering to the left. It's in the southern hemisphere, it's going to veer left. Thanks, Coriolis effect. If we look at the globe that's on the right, you see that these winds are being affected by landmass and the friction, so it's not as ideal as what we see on the left. So noticing those wind patterns, let me point out what's happening here. If you bring your attention to 30 degrees north and the equator and 30 degrees north and the equator in the southern hemisphere, I want you to look at this band of wind pattern in this region here. So the wind is moving from the east towards the west this way. And specifically here in the Pacific Ocean, this is where that wind has the largest fetch. And if you remember, fetch is just the extent of ocean that the wind has to blow across. The more fetch, the more momentum it can pick up. This wind is really going to affect weather in this region. So think off the coast of North America, South America, here, Australia, Indonesia. This weather is affected by the wind patterns. It has a specific name. It's called the El Niño Southern Oscillation. This is what we're going to spend today talking about when we talk about the ocean and weather. Because it's an oscillation, that just means that the wind patterns are going to oscillate between La Niña events, neutral events, and El Niño events. First, let's talk about neutral events, and then what causes El Niño and what causes La Niña. So normally, this area here is the Pacific Ocean. So here we have North America, South America, here we have Australia. Normally the wind is moving from the east to the west. And because of that fetch, that large extent that the wind has to blow across, the wind is blowing the warmer water towards the west. In the Pacific Ocean, the water's actually about 2 feet higher on the west end than it is on the east end, and that's because the wind is carrying that water towards the west. On the west side, you typically have wet conditions, so because it's so warm, because there's a lot of evaporation, you have a lot of rain in the west region. In the east, cold, nutrient-dense water upwells to replace the water that's being pushed off by the wind. So here you have a lot of bioactivity. There's a lot of plankton and zooplankton and fish and whales and seals that live along the eastern coast. Typically it's dry, and it's dry because there's not a lot of humidity. The oscillation happens between La Niña and El Niño. La Niña is when those trade winds strengthen. If the trade winds strengthen, this rainy, warm region is going to be pushed even more to the west, which is going to cause an even stronger upwelling in the east. With El Niño, those trade winds are going to weaken, and so this rain isn't going to be pushed as far, and because of that, it's going to move farther east, so this dashed little arrow just means that the wind's not pushing that warm water as far. And because of that, there's going to be less upwelling. So dashed arrow, little bit of upwelling that happens. La Niña, El Niño happen when winds change the strength that they have. And that just happens when low pressure and high pressure systems change, which they naturally do. So let me point out how El Niño and how La Niña affect weather, and then we'll be done. So again, normal conditions. Wind is moving from the east to the west. It's pushing this warm water towards the west. In the west, you have these rainy conditions. La Niña, this rainy, warm region gets pushed even more west. El Niño, this warm, rainy region doesn't get pushed as far, and instead you'll find it somewhere in the middle of the Pacific. So with El Niño, when those trade winds weaken, the warmer water moves towards the east. The sea surface temperature is going to increase by 6 to 8 degrees Celsius. That's because there's not a lot of upwelling and the cold water is not making its way to the surface. These El Nino events happen. It'll oscillate anywhere between 3 to 7 years. You'll have these El Nino events. And because of these El Nino events, there's not a lot of rain over Australia. You'll have a drought. Not a lot of rain in Indonesia. You'll have a drought. And without the upwelling that happens along the coast of South America, the fish population reduces. With La Nina, when these trade winds strengthen, the water warms in the west, gets pushed even farther west, but the sea surface temperatures are going to reduce from about 3 to 5 degrees Celsius. And that's because the cold water that was underneath is now upwelling even more. With that upwelling, there's increased fish populations around the South American coast. Because this rainy weather gets pushed even more west, you'll typically have flooding in Indonesia, flooding in Australia. So let's point out the impacts of El Nino on weather across the globe. So notice here that the trade winds have not pushed that wet region all the way to the west. So the wet and warm region is out here in the middle of the Pacific Ocean. It's dry across Australia, across Indonesia. We're actually in the middle of an El Nino event now, which is why Australia is facing wildfire and drought. As a country, you have to pay attention to when El Ninos or when La Ninas occur. So there's actually buoys set out here in the Pacific Ocean that monitor sea surface temperature. And that monitoring is to predict whether we're continuing towards an El Nino or we're continuing towards a La Nina. For Australia, they pay attention to these events because they don't plant certain crops in drought-prone regions during El Nino, because it would just be unwise knowing that there won't be rainfall because of the El Nino event. While it's dry here in the west, in the east, especially here along the coast of California, this is typically when California experiences flooding because it's wetter here on this side. Looking over at La Nina is when these trade winds are very strong and they're pushing that wet region even further west. So this is typically when Australia and Indonesia experience flooding because there's so much humidity in the west. In the east, this is typically when California experiences droughts because they're not experiencing as much rainfall. It's not as warm, not as humid.